Okay, this is a discussion about radiation. It follows pretty closely to an article that I've posted at my blog. There will be a link for that article in the description below. There are different types of radiation, and there are different ways of describing and classifying the radiation. For example, heat is a type of radiation, light is a type of radiation, microwaves and radio waves are types of radiation. Nuclear energy is a type of radiation. And you might hear them described as, electromagnetic radiation, ultraviolet radiation, kinetic and thermal, and nuclear radiation. But there's another way that's used to differentiate the types of radiation, and that's whether it's ionizing or not. Ionizing radiation can ionize atoms. And to understand what ionizing means, you have to kind of understand a little bit about the structure of an atom. Now, an atom's made up of subatomic particles, which are electrons, which have a negative charge, protons, which have a positive charge, and neutrons, which have no charge. An atom has a nucleus, and the nucleus is often surrounded by these orbiting electrons. Now, what an ion is, it's what happens when there's a different number of electrons. And what ionizing radiation can do is it can come in and knock out these electrons and ionize or make ions out of these atoms. Because when an atom is electrically neutral, when it has the same number of protons and the same number of electrons, and the charges of plus and minus balance out to zero, it's not an ion. It's when maybe it has less ions and less electrons, and like if it lost an electron, it would have a positive charge, or if it gained an electron, it would have a negative charge. And that's what our ions are. There's another ways that atoms can change, and that's by being an isotope. And what an isotope is when it has more or less neutrons. And when it has more or less neutrons, it really affects the stability of atoms. And when an atom is unstable, it's called radioactive because it releases energy to become more stable. So these are some other words here that are important to understand, like atomic number is the number of protons. This has 2 protons. And the atomic number is what defines what element it is. Because each atom and each element, an atom of each element always has the same number of protons. Otherwise, it'd be a different element. But if it has a different number of neutrons, it's called an isotope of an element. And if it has a different number of electrons, it's an ion. Let's take a look at what's called a periodic table here. This shows the atomic number of each element. Hydrogen has always 1 proton, and its number is 1, because the atomic number is equal to the proton number, or the number of protons. Sodium has 11 protons. Magnesium has 12 protons. Calcium has 20. Now let's go ahead and try to focus on what are some radioactive elements and what are their atomic numbers, excuse me. You have uranium has 92 protons. Plutonium has 94. Cesium is another element that can become radioactive, and it's 55. Iodine here at 53. And let's go ahead and go back to understanding those other terms. So that was all about the atomic number, the number of protons. So there's always the same number of protons in the same element. So if I'm describing an atom with 2 protons, I'll always be talking about helium, right? Because helium has 2 protons because its atomic number is 2. These other numbers are important too, like the mass number. The mass number is the total number of nucleons, protons and neutrons together. So if you took the number of neutrons, which is 2, and you took the number of protons, which is 2, and you added them together, you would have the mass number. And a mass number is usually written like at the end here of like, it's a way of just defining the isotope. Because if it's uranium, you would know how many protons it has. But so when you write the mass number, it's kind of like saying, okay, there's 235 nucleons in uranium, which has 92 protons. So you already kind of know the neutron number, or how many neutrons there are. And the reason these numbers are important is because the isotopes with a different number of neutrons each have their own properties, and some are more stable and some are more radioactive. Like uranium-235, for example, is a lot more stable than uranium-236. So just adding one extra neutron can make an element or an atom really unstable and radioactive. So remember, this is the mass number, is the number of neutrons. And sometimes they write it up here, and they'll also write the atomic number down here sometimes as well. And I'll show you a picture of that maybe later. So when an atom is radioactive, or an isotope is radioactive, they might call it a radioactive isotope. They might also call it a radioactive nuclide, or they put the words together and they say radioisotope, radionuclide. Okay, and when an atom is radioactive, it might release at least three different kinds of radiation: alpha particle radiation, beta particle radiation, and gamma ray radiation. And here's a depiction of the different types of radiation that might be released. An alpha particle is actually a lot like a helium nucleus, but it doesn't have those electrons, so it would be like a helium ion, but it's moving quite quickly. It gets shot out of a radioactive isotope, usually a quite large one, and it gets shot out at about 5% of the speed of light. That would change this isotope's mass number because it's losing 4 nucleons, and it would also change its atomic number because it's losing those 2 protons. So this would transmute or change into another element after releasing that alpha particle. But these alpha particles are considered, also considered some of the most damaging radiation, as well as this isotope here. Even because of the energy released, it can be ionizing and damaging as well. And so these kind of particles are pretty damaging, to your health. An alpha particle, though, doesn't penetrate very far. Like a piece of paper will stop the particle, so will the barrier of your skin. But if you ingest an alpha particle or an isotope that releases alpha particles, that can cause a lot of damage to your health. It can damage the cells, maybe result in lung cancer eventually. So one atom that you may have heard about is called radon, or radon gas. That's an alpha particle releasing radionuclide or radioisotope or element. So that's alpha particle radiation. Beta particle radiation is actually made up of electrons, and they're fast-moving electrons that are almost at the speed of light, and they also can ionize atoms or knock other electrons out of the orbits of other atoms. So that's beta particle radiation. And a beta particle radiation, the electrons that get shot out, they don't come from the orbits. They're actually what happens when a neutron, which is neutral, it will kind of decay into a proton, and an electron will shoot out of it because that's the process called beta decay. And so one of the neutrons is changing into a proton, and so this element changes as well, or transmutes into a different element that's got an atomic number 1 higher because one of the neutrons is now a proton. So, that's something that you're kind of considering as well. But the thing is, this electron shoots out really fast and it can ionize atoms, and that's called a beta emitting particle or beta emitting radioisotope. And there's also something that goes out as well. It's an anti-neutrino, which doesn't really have health impacts. So that's a beta particle, and it can be stopped by like an aluminum shield, or maybe aluminum foil, or wood as well as a good shield. And for these reasons, that these things can be stopped by those things, as long as you don't inhale them or ingest those things, or they'll get past like the cuts in your skin. Sheltering in place. If you stay like in your house locked up, if you shut all the windows, keep the air vents and the air conditioner off, you can be kind of protected from these types of radiation pretty effectively. Whereas gamma ray radiation, which is kind of like a ray of photons, kind of like light, or an X-ray, maybe like a really strong X-ray, it goes through these things, but a barrier of lead would stop it. And that's gamma ray radiation. And it's just a way for the isotopes to release energy, but it doesn't change the atomic number, or the number of protons, or the number of neutrons. And so it stays kind of the same, but it's still releasing this radiation that's ionizing radiation. And there's one other kind of radiation too. It's called neutron radiation, which is what's fueling nuclear reactors. So this is a process of a neutron radiation, and it's what nuclear reactors run on, a process called nuclear fission. Fission is what happens when a neutron enters an atom and makes it an unstable isotope, and then that unstable isotope fissions or breaks into at least two fragments, which are usually different elements, and it releases extra neutrons. And this can become a chain event if you have uranium-235 is a pretty common nuclear reactor fuel, and there's a lot of uranium-235. These neutrons then can go and find other uranium-235, do the same thing, and it releases a lot of energy, can make a lot of heat. Reactors usually have to be kept cool. And this is a diagram kind of what goes on inside a nuclear reactor. There's fuel rods, and that's where, maybe the uranium or plutonium is, and the fissions are occurring. You can see the neutrons are going to want to go and contact and, bombard or radiate these uranium or plutonium atoms and create the fission. But when the fission happens, these extra neutrons that get blown out or get go out in the process, they're moving too fast, so they go to a moderator to slow them down so they can contact these other fuel atoms and better, and create fission better, and keep that chain reaction going a little better. So there's a moderator there to slow them down, but there's also something called a control rod, which will absorb extra neutrons, which will keep that process from going too fast. Control rods usually will drop in automatically in a nuclear reactor incident. Sometimes they have to be, I don't know if they have to be, but they're placed in by hand. Like a worker will put it in to slow down the properties. So that's a way for controlling the rate at which that fission occurs. But neutron radiation is really penetrating, actually, but it's stopped by water. It's usually like you think of lead. It's a big barrier, or steel or metal, as being something that would stop radiation. But it's the lighter elements that stop the neutrons, because the neutrons would penetrate these other things. But like concrete and gravel will help block neutron radiation. But the thing is, neutron radiation is not very common outside of the reactors. But it's also what happens in nuclear weapon detonation. But and it can radiate your body. It can go in and make radioactive isotopes out of the atoms in your body. But in your body, it wouldn't really make a chain reaction. And also, you might encounter neutron radiation as from handling radiated materials.